Good day, my great turns. Today we're going to be talking about the topic of longitudinal wave. Yes, this is a very, very beautiful topic. First and foremost, we're going to is just a little summary of what is a longitudinal wave. So first and foremost, we're going to look at the definition. The definition of a longitudinal wave is that it is a wave in which the particles of the medium vibrate parallel to the direction of motion of the wave. Yes, the particles in the medium vibrate parallel. Okay, for example, let's say this red line here represent what? The direction of motion of a wave. Yes. Then these lines will be what? Will be mitigating what? Will be vibrating parallel. Parallel to what? To the direction of motion. Yes, hopefully that is understood. As you can see here, it is indicated what? The direction of motion is what it is going on in this direction. Maybe you can call it is going to the right. Yes, but the motion of particles in spring are going what? Back and forth. As you can see, they're making what? They're making something like a spring. Yes, as we can say. So there is what? There is the definition of a longitudinal wave. And longitudinal wave is part of the what? Of the mechanical waves, which is mechanical wave consists of two types of waves, which is the transverse wave and the longitudinal wave. Yes, if you haven't watched the past videos, make sure to check them out because they will be very, very helpful. So you have what we call a rarefaction and a compression. So what is a compression? A compression is a region of high pressure in a longitudinal wave. And rarefaction is the opposite. It is a region of low pressure in a longitudinal wave. For example, let me show you this diagram here. So as you can see here, there is a high pressure because when the springs are closely packed together, they indicate a high pressure. As you can see here, they are also closely packed together, indicating what? A high pressure. Also here, same thing. But then here they are starting to be open, meaning that what? They are a low pressure. When they are far apart, they indicate a low pressure. Yes. So they're called what? The rarefaction. Yes, hopefully that is understood between the compression and the rarefaction. So if they ask you the difference, just say a compression is a region of high pressure in a longitudinal wave, and a rarefaction is a region of low pressure in a longitudinal wave. Here's my great turns. A quick summary. So we have head on to the wavelength of what? Of the longitudinal wave. So it is very easy to identify the wavelength. The wavelength is just the distance between the center of one compression to the center of the next compression. Very easy. Or the distance between the center of one rarefaction to the center of the next rarefaction. For example, for blue, let's indicate rarefaction. So for rarefaction is this one down here. Yes. So the distance from here to what? To this next one. The distance from here to here is what? It is considered as the wavelength. Yes, as you can see, there's the start of what? There is the start of the rarefaction, and there's also the next start of the rarefaction, indicating what? The total wavelength. Then let's go to what? To the compression. So the compression here, as you can see, there's the start of the compression and there's the start of another compression. Yes. So this will indicate what? The wavelength of what? The wavelength of the wave. Yes. So of the longitudinal wave. So this is a quick summary. Hopefully you got that all together, and on future videos you might practice frequency, the period, and calculating wave speed on longitudinal wave. I thank you, my great turns. Continue studying harder, and I wish you all the best.